in the previous class we discussed the concept of limits, is it? So here just I wrote the definition another one time. What is meant by limit, that is LHL, and what is meant by RHL. So here it is, my dear students. Limit of f of x as x tends to a is equals to L. How to read that also I explained, but just I am recalling here it is. So how to read, my dear students? Limit of the function f of x as x tends to a is equals to L. So this is the notation we are using in limit concept. So we can read it as limit of the function f of x as x tends to a is equals to L. This means what then? This means as x tends to a or x approaches to a. It means if you are giving the values, x values as very close to a, not exactly a, very close to a, as x tends to, or you can write it as x approaches to a, then the function f of x values also tends to, exactly it tends to the values L. F of x values also tends to L. This is the meaning if I write this much. So this is the meaning, my dear students. I hope you understood. This is the meaning we can write. But what should we understand in our mind? We should understand that ಯಾವುದೇ ಒಂದು ಫಂಕ್ಷನ್ f of x ಅಲ್ಲಿ x tends to a ಅಂದ್ರೆ ಫಂಕ್ಷನ್ ಅಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ಲಿ a ಅನ್ನೋ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತಾ ಇಲ್ಲ, a ಗೆ ನಿಯರರ್ ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದಾಗ ಬರ್ತಕ್ಕಂತ ಆನ್ಸರ್ ಫಂಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ಏನ್ ಸಿಗ್ತಾ ಇದೆ ಅಂತ ಅರ್ಥ, L ಸಿಗ್ತಾ ಇದೆ ಅಂತ ಹೇಳಿ ಅರ್ಥ. ಸೊ ದಟ್ ಇಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ದಿಸ್. Here it is limit concept. And next we discussed what is LHL. LHL means what I told, left hand limit. The function values as x tends to at a particular point, if you are calculating the function value at x is equals to a, means you are giving the values very close to a from the left side neighborhood values you are giving. So therefore we can call it as LHL, and that is written like this: limit of f of x as x tends to a minus. A minus means left side of the values of the, here it is, left side of the x is equals to a point you are giving. So therefore we can write like this. And RHL means right hand limit, that is nothing but limit of f of x as x tends to a plus. X tends to a plus means in the function you are giving the values right to the point a, therefore we are writing a plus. Don't think this as negative and positive. This is the just notation. Left side of this is a minus means left side of the point x is equals to a values. A plus means right side of the point, right side values of the point x is equals to a. That much. Understood? And next, my dear students, if LHL is equals to a limit exists, limit, when we say that limit exists, we say that limit exists ಆಗ್ತದೆ ಅಂತ ಯಾವಾಗ ಹೇಳ್ಬೋದು ಅಂತ ಹೇಳಿದ್ರೆ, if left hand limit is equals to right hand limit. If LHL is equals to RHL, then we can say that limit exists. Understood? And that all we discussed with example we discussed in the previous videos. Here just I wrote here this the definition. Understood? And next, what are indeterminate forms? What are indeterminate forms? So indeterminate form means which the values we cannot determine, say 0 by 0 or infinity by infinity, infinity plus or minus infinity. Plus or minus means infinity plus infinity is also indeterminate form, infinity minus infinity is also indeterminate form, and 1 to the power infinity, 0 to the power 0, still some more are indeterminate forms are there, but mainly we are using these forms. So this we can call it as indeterminate forms. Understood, my students? Next we will study algebra of limits. What is algebra of limits? Algebra of limits means how to add the two limits, how to add, how to subtract, how to divide, how to multiply. This all we can call it as addition, subtraction, all these operations generally we can call it as algebra. So now we are studying algebra of limits. Understood? So what it says, let f and g be the two functions such that limit of f of x as x tends to a and limit of g of x as x tends to a exist. Both must exist. And then we can say exist means what? LHL and RHL must be same. If these two functions exist, then we can say we have the results. What is that? We can say that limit of f of x plus g of x as x tends to a, this value is equals to, if you take the two functions, if you add as limit x tends to a, then this value is same as if you solve the limit of f of x as x tends to a and limit of g of x as x tends to a. If you solve here this separately and then if you add, these two values are equal. This is the first property. Like that, if we subtract, then also here it is limit of f of x minus g of x as x tends to a. If you subtract the two functions, this value is, and if you apply the limit, this value is also same as if you calculate separately limit of f of x as x tends to a and limit of g of x as x tends to a. Separately if you calculate the limit values and then if you subtract, means that value is also same. Equal sign is there in between. Clear? Like that, if you multiply any two functions and then if you apply limit as x tends to a, this value is same as limit of f of x as x tends to a into limit of g of x as x tends to a. This is multiplication. And now divide, here it is division. So if we have two functions f of x and g of x, as I told, f of x divided by g of x, if you first divide the two functions and if you apply the limit, this value is same as limit of f of x divided by limit of g of x. Here we should write it as x tends to a and here it is also as x tends to a. Both these values are same. And similarly, my dear students, if you are multiplying with the lambda means any real number, scalar quantity, any constant, 1, 2, 3, whatever your choice, your wish. If you multiply any constant with the function and if you apply the limit, that value is same as if you take it out, if you first calculate limit of the function and as x tends to a, if you calculate the first the limit value of the function and then if you multiply with that constant, here also the values are same. So proofs are not required. Just remember these results. These are useful while solving the questions. I hope you understood. If you have any doubts, you can comment me. I'll reply for that one. So please pause the video to note it down, my questions. Next I'll discuss the questions based on this. Please pause the video to note it down. Yes. Now write down the questions, my dear students. Next, I wrote the questions, here it is. So we will solve one by one. Please see it is, my dear students. Here the first question is, these are all 1 mark question, I mean simple questions. So first question is evaluate, here it is. I am going to solve the first one. So answer for the first one. So what is that they given to you, my dear students? Limit of the function x square plus 1 whole divided by x plus 100 as x tends to 1. My dear students, always you check whether by substituting that x as here it is x tends to 1 they given, means whatever x tends to values they will give you, that value substitute in the given function. So if I substitute here, it is means x square value is 1. X value is 1 means x square. 1 square value is 1. 1 plus 1 divided by, here it is 1 plus 1 is 2 divided by, here x value is 1. 1 plus 100 is 101. So if you are directly getting the values, means just put that value, x values in the given function. Suppose if you get the indeterminate form, means in that case we have different methods. It means we should factorize and then calculate. So that I will discuss later. As of now, if you substitute the x values, whatever tends to they will give you. If you substitute that values in the given function, if you are getting some values, it means if you are not getting indeterminate form, means just simplify, put that x value and simplify. That is your required answer. Understood? So here it is not in the indeterminate form. So therefore this value, this answer is here it is x tends to 1. The given means put the x value as 1. So 1 square plus 1 whole divided by 1 plus 100. So this is 1 square is 1 plus 1 divided by 100 plus 1 is 101. So therefore 2 divided by 101 is answer for this one. So please pause the video to note it down. And next I will move to the next second question here, my dear students. So what is the second question here? This second question is limit as extend. Here it is limit of x minus 22 by 7 as x tends to pi. So here also this is indeterminate form, you can check. So just substitute, my dear students, here this x value as pi. So here it is substitute x value as pi. So this will give you pi minus 22 by 7. Understood? Please remember x tends to pi. You may have doubt that here pi means 22 by 7. 22 by 7 minus 22 by 7. God cancels. You should not think like that, because what I told, my dear students, x tends to means what? X tends to means we are giving the values nearer to this one. Neighborhood of this pi we are giving. Not exactly 22 by 7. X tends to is there. So therefore simply write pi minus 22 by 7. This is the answer for the second one. Next, third question, answer for this one. So what is that? Limit of ax plus b whole divided by cx plus 1 as x tends to 0. So in this function, my dear students, we should give the x value x tends to 0. So what happens if this x value 0 means a into 0 plus b whole divided by c into 0 plus 1. So this is nothing but a into 0 is 0. Leave that one, only b you will get, whole divided by c into 0 is 0. 0 plus 1 is 1. So therefore the final answer is b here for this one. And next we will solve the fourth one. So fourth one is what they given? Limit of 4x plus 3 whole divided by x minus 2 as x tends to 0. This I am solving here. So again what will do here is just substitute x value as 0. If you substitute x value as 0, so what happens here is 4 into 0 plus 3 whole divided by 0 minus 2. So this is nothing but 4 into 0 is 0. Leave this term. Only remaining is 3 divided by 0 minus 2 is minus 2. So this will give you plus minus minus 3 by 2 is your required answer. Understood, my dear students? So like this you should solve. So these are all indeterminate forms, not indeterminate form. If you have indeterminate form, how to calculate, that we will discuss in the next video. Understood? So please pause the video to note it down. Still, if you have any doubts, you can comment me. I will reply for that. Thank you.